Follow me. Let me solve the problem that involves using relative abundance to calculate relative atomic mass of an element. Let's go. It is not difficult. All right. We have example 2. The atomic number of an element is 17. When you hear atomic number, it simply means what? Number of protons. So we have solution like this. All right. It has different atoms. For it to have different atoms, it means that it experiences what? Isotopy. That means it has isotopes. All right. It has different atoms containing 18 neutrons and what? 20 neutrons with a relative abundance of 75% and what? 25% respectively. All right. So it means that the atomic number is what? We have it to be 17. So we say that when it comes to isotopes, they have similar atomic numbers but different what? Atomic masses. So atomic masses here now, we have atomic masses. We have this one. We have it to be atomic number, that is proton number, which is 17. Remember I said atomic number means proton number. Okay, let me write it first before I will explain it so that you won't get confused. We have it to be what? Proton number. Can you see that? Plus neutron number. Can you see that? Proton number plus what? Neutron number. That is what will give us what? Atomic mass. Can you see that? All right. So here now, we have an atomic mass to be what? Proton number plus what? Neutron numbers. So for these two atoms we are talking about here, let's say atom 1. Let me call it atom 1 like this. So we have it to be proton number is this, while the neutron number is 18. Can you see that? All right. When you add this thing together, what do we have? We have 35. Can you see that? Then we have atom 2. Atom 2, we have 17 because the proton numbers are the same. All right. Then the neutron number of this one is 20. We have 20 like this, which means what? 37. Can you see that? So the atomic masses are what? We have 35 and what? 37. Is it clear? All right. So for us to calculate relative atomic mass of this, we call it relative atomic mass of this element. We use the abundance to multiply the individual mass. All right. So what do we have here? We have 35. Can you see that? We have 35 times, we have what? 75%. Can you see that? Then we have plus. We have 37 times 25%. Can you see that? Is it clear? That is how to find the relative atomic mass of this. All right. So what do? It is not difficult. So we now say this is equal to, remember this means 35. 75% simply means this. Can you see that? This over 100. Can you see that? All right. So plus this means 37 over 1 times you have 25 over 100. Can you see that? When you hear 25%, it means 25 over 100. When you hear 75%, it means 75 over 100. All right. So that is it. We have like this. All right. So what do we do next? I will multiply 35 and 75. 35 and 75. Let me do it here. I have 75 times 35. Can you see that? 5 times 5 will give me what? It will give me 25. I'll write 5 carry 2 like this. 5 times 7 will give me 35 plus 2, it will give me 37. 3 times 5 will give me 15. I'll write 5 carry 1. Then 3 times 7 will give me 21 plus 1. I will have 22 like this. Can you see that? Bring down this one. This will give me 5. When I bring down this one, I'll have 12. Carry 1. Put here, I'll have 6. Then I'll bring down this. Can you see? I will have 2,600. So it means that this time this will give me 2,625. So let me write it 2,625. Can you see that? Then 1 times 100 will give me 100. Can you see that? It will give me 100. All right, so that is how to obtain this. I'll clean it because I still need this space. All right, so I have this. I'll resolve it to this. Next one I have is 37 times 25. All right, so I have this one times 25. This time this will give me 35. Write 5 carry 3. This time this will give me 15 plus 3. I have 18 like this. This time this will give me 14. I write this carry 1. This time this will give me 6 plus 1. I have 7 like this. Then bring down this. I will have 5. Bring down this. I have 12. Carry 1. Bring down this. I have 9. Can you see? So I have 925. So this will give me 925 all over what? 100. Can you see how I multiplied it? It's not difficult. All right, I'll clean this so that I will have enough space to continue what I'm solving. All right, so here now, notice that we have this. The LCM of this will give us what? 100. Can you see that? When 100 divides 100, it will give me 1 times 2,625. It will give me 2,625. When 100 divides 100, it will give me 1 times 925. It will give me 925. So I will add the numerators. So I have 2625 plus I have 925 like this. When you add this, 5 plus 5 will give us 10. Write 0, carry 1. Put here, you have 5. This plus this will give me 15. Write 5, carry 1. Put here, you have this. So I will have 3,550. 3,550. So that means that when I add this thing together, I'll get 3,550. Everything all over 100. Is it clear up to this point? All right, at this point, I'll cancel 0, cancel 0. When I cancel 0 again, I'll move like this, I'll have like this. So that means that this will give me 35.5. Can you see? So relative atomic mass of this element is what? Is 35.5. 35.5. Can you see that? 35.5. All right, so that is how to obtain it. I believe that you enjoyed the way I just solved it. Remember, this is Engineer Kene tutorial. Like this page, follow this page, and share this video so that it will get to the right students that need to acquire this mathematical knowledge in order to get educated. Bye.